Akshay Kumar Surde, Assistant Professor, Department of Mechanical Engineering. Today we will solve the numerical based on shear stresses in beams. Learning outcome: at the end of the session, students will be able to apply bending and shear stress formulas to determine the safe load on a beam. Also understand structural behavior under point loading for design applications. So, problem based on bending and shear stresses. The statement of the problem: a simply supported beam of span 1.3 meter carries a point load W at the center. The cross section of the beam is 250 mm deep and 150 mm wide. The maximum flexural stress due to the bending is 7 Newton per mm square and 1 Newton per mm square in shearing. Calculate the safe load W. So, first of all, we will take the given data from the statement. So, length of the span beam is 1.3 meter and it is a simply supported beam AB of length 1.3 meter and it carries a point load at the center of the beam and the magnitude is W Newton. The section of the beam is rectangle having width 150 mm and depth 250 mm. So, depth is 250 mm and width is 150 mm. The bending stress is 7 Newton per mm square and allowable maximum shear stress is 1 Newton per mm square. We have to calculate the safe load that beam can carry. Therefore, first of all, we will calculate the maximum bending moment and maximum shear force to which this beam is subjected. So, as we know, the load is acting at the center of the beam. The reactions at A and B is half of the total load, that is equal to W by 2 each, and the maximum shear force for simply supported beam carries point load at the center is nothing but it is W by 2, and maximum bending moment to which the beam is subjected is WL upon 4. At the support, the bending moment is always 0. Now, the section which is given is a rectangle having width 150 and depth 250 mm. So, the position of the neutral axis for this rectangle section from the top edge, it is at half of the depth. So, it is 125 mm. So, y is equal to d by 2, which is equal to 125 mm. Now, first of all, we will use the bending equation. M by I is equal to sigma max divided by y max. So, for rectangle section, the moment of inertia about the neutral axis is given by BD cube by 12. So putting the value of B and D, we can determine the moment of inertia for the rectangle section, and the moment of inertia for the rectangle section is 1.953 into 10 raised to 8 mm raised to 4. Maximum bending stress is given 7 Newton per mm square. Ymax we have already calculated, that is 125 mm. Hence, M is equal to sigma max divided by Ymax into moment of inertia. So putting the value in the above equation, 7 upon 125 into moment of inertia is 1.953 into 10 raised to 8. So we will get maximum bending moment M is equal to 10.93 into 10 raised to 6 Newton mm. So this is your maximum bending moment to which this beam is subjected. So bending stresses are calculated corresponding to maximum bending moment, and hence for simply supported beam carries point load at the center, the maximum bending moment M is equal to WL by 4, and the value of maximum bending moment we have obtained 10.93 into 10 raised to 6 is equal to WL by 4. So from this we can calculate the point load W, 10.93 into 10 raised to 6 into 4 divided by length of the beam, that is 1.3 meter, that is 1300. So point load W is 33,654 Newton, that is equal to 33.65 kilo Newton. So by using bending stress formula, the load W is 33.65 kilo Newton. Similarly, the maximum shear stress is given to you. So maximum shear stress is 1 Newton per mm square. So for rectangular section, maximum shear stress tau max is given by 1.5 times of average shear stress, and your average shear stress tau average is maximum shear force divided by area of the section. So shear stress tau max is 1 Newton per mm square is equal to 1.5 into maximum shear force, as we have calculated for simply supported beam carries point load at the center, the maximum shear force is W by 2 divided by area of the section, that is B into D, which is equal to 150 into 250. So by solving this particular equation, you can get 0.75 into W divided by area of that particular is 37,500, and hence 37,500 divided by 0.75 is equal to W, and therefore the point load W by using shear stress consideration is equal to 50,000 Newton, which is equal to 50 kilonewton. So we have obtained the safe values of point load by using bending stress equation. We have obtained 33.65 kilonewton, and by using shear stress consideration it is 50 kilonewton, and henceforth the safe load which to which the beam is subjected is equal to 33.65 kilo Newton, which is the least value of out of the two, and hence the safe load is obtained by using the bending stress equation or by bending stress consideration. This particular problem is solved by using the references of strength of material by R.K. Bansal and strength of material by S.S. Bhavikatti. Thanks.